In the last video, we talked about conditional operators in Grasshopper. Conditional operators evaluate numerical inputs based on certain condition and return Boolean results. We covered equality, similarity, larger than, and smaller than operators. So in this tutorial, we're going to talk about combining multiple conditional statements by comparing and matching Boolean results. And to do that, we use logical operators. We're only going to discuss few the most commonly used logical operators, but just for you to know that there are more of them. So let's begin with gate AND. As the name suggests, gate AND operator returns true only if A and B inputs are true. So both inputs need to be true for the result to be true. Let's have a look at how it plays out in this example. So currently all gate AND output results are false because we don't have matching true values in the input parameters, so between A and B lists. Let's modify our definition to change these results. We're going to use number slider for that. Let's double click on canvas and define the bounds for the number slider. Let's say for -1 to 10. And then using Alt key, let's create a copy. Let's connect one of the number sliders to B input in the larger than component, and then the second one to the B input as a second number to the smaller than component. Now let's adjust these inputs. So let's say we want to have something smaller than 6 but larger than 2. So in this case we have some overlapping or matching true values in both of these lists. Therefore, gate AND operator returns 3 true values, specifically items with indices 3, 4, and 5. So again, gate AND statement is if A is true and B is true, then return true. Let's go check another one. Again, under math operators, let's pick gate OR. And again, as the name suggests, gate OR operator rule is if A is true or B is true, then return true. So let's see how this works in this example. I'm going to move some panels around for clarity. So at this point, all the results from gate OR are true. And this is because we don't have overlapping false values in the inputs. Let's change that by moving second number slider for larger than component to number 7. So now we have 2 overlapping false values between the inputs. So you can say that gate OR returns false only when both A and B inputs are false. Let's grab another operator. Let's take gate NOT. This operator is less complex. As you see, it has only one input parameter. I'm going to choose smaller than output to input here in gate NOT. And what it does, it flips the input values and returns the opposite ones. So if the input value is true, then it's going to return false. And if the input value is false, then it's going to return true. The next operator we're going to discuss is going to be gate XOR. Let's connect larger than output into A input and smaller than output into B input. And I'm also going to quickly reorganize the canvas so that it's clear to you. So gate XOR returns true only when the input values do not match. So either we have true and false or false and true. So I'm gonna manipulate the definition a bit. Now we have some overlapping true values as inputs, and you can see in the output that these items are returned as false values just because they are the same, they match. Since we've talked about Gate Xor operator, we also need to talk about Gate Xnor operator, which is the opposite of the Gate Xor, and it returns true only when both input values match. So it could be true true and it could be false false for Gate Xnor operator to return true value. We have covered all that I wanted to cover in this tutorial, but before we part, I'd like to mention that some of the logical operators have zoomable users interface. So if you zoom in on it enough, you can add additional input parameters. I encourage you to investigate which logical operators have zoomable users interface and how these operators would work with more than 2 inputs. The toggles that I'm currently using here are disabled so that you wouldn't see the result in the output panel. So this is it for this tutorial, and I will see you in the next one.